In this module, we will go over the process of learning parameters or training. We will discuss a particular cost function called the mean square error. In the last section, we saw a toy problem where we used one example to obtain our model parameters. In this section, we will demonstrate a method to use your entire dataset to obtain your model parameters. Instead of obtaining the model parameters for just one sample, we obtain the parameters by minimizing the value for multiple points. We can visualize this with little squares whose areas are equal to the sample error. Sometimes we divide the error by the number of samples. We can visualize this as taking the average area of all of the little squares. The sum or average of the loss is called the cost. We will continue to use the subscript L in our mathematical notation, as much of the PyTorch documentation refers to it as the loss function. Symbolically, the cost function looks like this. It's a function of two variables. The first variable is the slope, and as we adjust the slope, the value for the slope parameter changes. Similarly, it is also a function of the bias. The bias controls the offset of the line. We can also take the derivative of the cost function as follows, and we can also perform gradient descent on the cost function. Let's consider the following example where we just examine the slope. The top plot shows a data space. We have the estimated points on the top and the actual points. The bottom plot shows the cost function, where the yellow point represents the current value of the parameter and the loss generated. When we calculate the derivative, we get a negative number. Plugging it into the present iteration of gradient descent, we subtract a negative times a negative number, and this gives us a positive value. We add this positive value to the parameter. As a result, the parameter moves in the positive direction, and the estimated points on the top are closer to the actual points on the bottom. In this example, the data points are on the other side of the line. We have the estimated data points and the actual data points. We see by taking the derivative, the result is positive. After proceeding with the next iteration of gradient descent, we see we get a positive number multiplied by a negative number. The result is we subtract a large negative number. The parameter value moves in the negative direction in the data space. The resulting line becomes closer to the actual data points. In this example, we have a data point below the line and another data point above the line. And then we have our two estimated points. Taking the derivative of the cost function, we get a negative number and a positive number. Therefore, the value of the derivative is extremely close to zero. As a result, the line barely moves. All the training samples in a training set are called a batch. As a result, this method is called batch gradient descent. We take the first sample, second sample, to the nth sample. To an example, we have a training set with 3 samples. Here's our training set. In this case, our batch size is 3. Our first sample is as follows. Our second sample is as follows, and our third sample is as follows. As you can see, our cost function is a function of the actual parameters w and b.